Alrighty, we are Project 22, the Assist Tech demo. I'm Amanda, this is Spencer, Diego, that's Kevin, and that's James. So our project is to create an off-the-shelf device in order to display all of Assist's current research, which is in environmental monitoring, health sensing, as well as energy harvesting. The problem right now is that there's not enough people invested in this, so just to show and demonstrate to them what Assist Research is doing and get people more involved, and then eventually also to use K through 12 outreach events, get people more invested in STEM as well, because that's definitely a lot of our future. All right, so we actually have two devices. So we have the wearable, which is going to be the environmental monitoring as well as health sensing, and then our secondary device, which is this device right here, is going to be our energy harvesting. So the wearable has a microcontroller that is then communicated with all of our sensors, the heart rate, the temperature sensor, the BME, which is VOCs, and then the ozone sensor all communicate through I2C, and then the ozone is over the ADC pin, and then that has a daughter board to power it with the battery, and that's all communicated through Bluetooth to handheld device on Android application, which we have right here. And then for the energy harvesting, we have a thermoelectric generator, which is fed into the Arduino. And then each of the piezos are fed into a filter and then voltage divider, and then fed directly into the Arduino after that. And then depending on which piezo you flick, different LEDs will light up. And then for the TEG, you'll have the array. So as you create more energy through this, which is through temperature, you'll create and light up more LEDs. The piezos are using kinetic energy, so like a bending and breaking, which we'll show during the demonstration.
So the hardest part about implementing this was the heart rate algorithm. Using our max sensor, we could not just take the raw data. We had to figure out how to filter it properly. And so what we did was we put it through a mean median filter, which looks for the largest differentials between sample points. Once we put it through that filter, it resembled more of an echocardiogram, like those that you see in the doctor's office. With that, we could properly detect our pulses, sample it over 10 seconds, multiply that by 6, and then you get your beats per minute, which you can see right here on the app.
Throughout the course of this project, we learned a lot of things about the process of product development. The couple of really important things are task delegation and team communication. Throughout the course of the project encompasses a lot of components. For example, VOCs, ozone, energy harvesting, health sensing, environmental monitoring. So properly delegating those tasks, making sure everybody had a balanced number of tasks. Not one person was responsible for all components of the project, as well as communicating between everybody, making sure everybody was on the same page for the entire scope of the project, making sure everyone agreed as to what the responsibilities were and what needed to happen in certain dates. As far as the process of development and design, we had to learn a lot of things. For example, designing a PCB, delivering tasks on time, scheduling, purchasing scheduling was an interesting little challenge to have. Purchasing things a week in advance rather than 3 days in advance. Just throughout the course of the project, a lot of things needed to be learned, and a lot of useful lessons were had.
Now we're going to have Diego here demonstrate the volatile gas and ozone sensing. The first thing he's going to do is the ozone sensing. As you can see, this bottom graph will spike once he exposes the wearable device to an ozone source, such as this ozone generator here. As you can see, the graph has spiked in response to the ozone being seen. All right, now what Diego's going to do is put some hand sanitizer, just ordinary old household hand sanitizer, onto his hands. And what's going to happen here is this volatile gas graph is going to jump, because as much as you wouldn't think about it, hand sanitizer is 70% ethyl alcohol, which is actually a volatile gas. It's now in the air around him.
Now we are going to demonstrate the energy harvesting device of the project. The goal of this device was to represent or to demonstrate the ability to harvest energy through heat, as James is now demonstrating. James is applying heat to our TEG, or our thermoelectric generator. That heat differential creates voltage, power, and lights up the LED array. The greater the heat differential, the more heat applied, the more power generated. 4 LEDs lighting rather than 2. The other component of the energy harvesting device is the piezoelectric materials. These materials harvest energy from kinetic energy. As James applies kinetic energy by bending and breaking, warping the piezoelectric materials, these LEDs will light up.
All right, so we had to do K through 12 outreach events. So we went to Washington Elementary and talked to a 3rd through 5th grade class who's aeronautics, so they had STEM background, and we just demonstrated all of our products, got some feedback. The only thing that they really said was maybe a little bit smaller because they have some small wrists, but they really interacted very well. We automatically, when we pulled out the Arduino without ever saying anything, a guy was like, hey, is that an Arduino Uno? Right away, he knew exactly what it was. As soon as we told them that they had to have some temperature difference, they started rubbing their hands together and started creating a different type of temperature so that they could light up more LEDs. And they were really great, really interactive, had some really good questions about everything, some of them wanted to buy the products, wanted to try and start to think of how you could apply this and where you could go with all of these products. So it was really good to get their feedback.